Alrighty, we're going to talk a little bit about Chapter 7. In Chapter 7, we're going to talk about object creation, very similar to variable creation. Okay. Now we're talking about the object itself rather than a variable. You all remember from Chapter 1, Chapter 2, we started declaring variables, initializing variables, instantiating variables, right? Same thing, except we're doing it to an object now. An object is a part of a method, right? You're looking at a specific instance where you have multiple methods that create this object. All right. For example, let's use a baseball. What do we have? We have the hard part of the baseball, which is a bunch of yarn wrapped in some sort of hard, I'll call it Mod Podge. Y'all remember Mod Podge? You know, you can make different creations out of it. It creates the form. Then you've got the leather wrapping. Then you have the stitching, right? Well, you have a method for the stitching. What color is the stitching? What type of stuff is the stitching, right? What kind of leather is it? Is it rawhide? Is it cowhide? What is the type of leather? Is it dyed yellow? Is it dyed white? Are there stamps on it? I mean, you see, you can think of it as characteristics. Of each characteristic is made by a method. All collective becomes an object, right? So Cody, he has on gray shoes, white socks, greenish tan pants, or whatever you call that color, a blue shirt. Okay, he has blonde hair, he has glasses. All those are characteristics of Cody. Cody is the object, and each one of these instances creates or part of this object. Does that make more sense to you now? Y'all kind of understand how it. Think of it as the methods are your characteristics. Okay, we're going to talk about assigning a reference to a method, testing objects for equality, and how you do it. There are two different ways to do it. One will not give you the correct answer, one will. Remember, we used the dot equals method. I believe it was Chapter 4, Chapter 5, where you give your variable dot equals, and then it's an equals method that comes out of the math class. Y'all remember that? That is how you test for equality. You don't use the comparison operator, because if you did a car 1 to car 2 and you did them, it's not going to equal out right, because you're talking about two different objects that are stored in two different places in memory, so they're never going to equal. Does that make sense? Passing reference variables or references as arguments. Method call chaining. When you do a method call, I'll show you a method call and then I'll show you how to chain it. Okay. Sometimes they're good, sometimes they're not so good as far as how you want to get this method done. Overloading methods, where you have the same method but you have multiple different characteristics or the different types of variables that you're using for the methods. Constructors, overloaded constructors would be the same thing as what we're talking about with the methods. How you're overloading, you call the constructor 4 or 5 times, have different output types. You have instance constants, class variables, class methods, and then how we get into using them and accessing them. We'll talk a little bit about constraints, and then we'll finish out with a summary, okay? So what we have here, we have 3 different spots here, right? A 1, 2, and 3. Instead of the bullets like we've had the entire semester, we're talking about the different types of things. Car. What is car? I'm talking about this first car. What is car? It is a method. It's actually a variable. Okay? The variable car is giving a variable name. It's the declaration of car to that car method. Does that make sense? Everyone with me? What about this line 2? What is that? This is object instantiation. What we're doing is we're saying, now my car that I've defined here in my variable called car is being instantiated with a new car method. Does that make sense? Very similar. Think about this. Let's say this was int, an integer car, right? Well, we're creating the instance of car with a new car method. Y'all remember doing that, right? The only thing different is instead of being an integer, this is a object called car. Does that make sense now? You see how it's very similar, just a different type. And then what we're doing here, we have car, right, which is our method. Year, which is the variable inside of that method, we're assigning a value of 2008 to. So these are the 3 things that you're going to do inside of an object. You create the object, you instantiate the object by telling it what the name of that object is, and then you assign the variables that are information. Pretty simple. Same concept as what you did when you were doing your main class, right? So once you create it, you're allocating memory for this particular object. then for the particular variable. Does that make sense? Yes or no? Yes. I want to see head shaking and verbalization so I can feel I can go on. And then what we're doing here is we're assigning 2008 to the year. Okay? Now, let's go through this as a code fragment. We're going to do this pictorially. All right? How would we do this? Anyone have a guess? First, I know, John did. I always forget it when he does stuff like that. When we instantiate a car, right? The car method, we have a block of memory that's put right here. We have no value to it, right? It's garbage. So this gets now put into the block of 1062 in memory. Does that make sense? Mm-hmm. So we have that 3 space there. Now I'm sorry, you're going to hear this over and over and over. We're assigning the value of 2008 into this memory block of car, because this is one part of that car, right? What are kind of variables when we talk about our characteristics of a car? Make, model, color, year, number of doors, transmission, type of engine, air conditioning. You know, you go and you look at that little thing that's on the window, the window sticker. Each one of those are a characteristic of that vehicle, right? What about a VIN number? You can assign a VIN number in here. So what are we going to do? Well, the result of assigning one reference variable to another is that both reference variables will point to that same object, right? Correct? Pretty simple. But with both reference variables pointing to the same object, if one is updated, the other is going to be updated, right? How many of y'all have ever heard of the hard link in Unix Linux? A hard link. That means if A equals C, B equals C, right? I change C, what's going to happen to A and B? They're going to change. You're going to look at here and just see what this value is, right? Right. That's what it's talking about. Or it could be also a symbolic link, because you're looking to this reference point variable, and if that reference changes from one, it's going to change for the other. Correct? Now that could be a problem, right? Why would that be a problem? Anyone have an idea?
Well, what if you don't want them all to be Ford Mustangs with...
Exactly. Exactly. How would we solve that problem? Anyone have an idea?
Create a new variable.
Well, you can create a new variable. So we have two objects here, two different cars, right? Mm-hmm. We've defined Stacy's car and we've defined John's car. Both of them is a new car, right? Mm-hmm. Stacy's car is not a new car yet. John's car we're going to set to a Toyota 2008 in silver. Now, I'm pointing Stacy's car to John's car. So what have I done here at Stacy's car?
Stacy's car has the exact same...
Stacy's car is a silver Toyota 2008, right? Mm-hmm. But now if I say Stacy's car, I want to set it color to peach, what have I done?
You made John's car peach too.
Oh. No.
Because I've set Stacy's car, this instance variable will be peach. So John's will stay the same. Mm-hmm. Stacy's set color will change. Now, if he changed to a 2012 Dodge, Stacy's car is going to turn to a 2012 Dodge. Yeah. Does that make sense now? Now, could that be a problem? What if they did that in the DMV? How much would that screw everyone around? Everyone would have a 1945 Ford Falcon, right? It would be pretty bad. Okay? Like I said, the problem is assigning it. It's not at the very beginning is going to be the problem, because you're still going to have your silver Toyota 2008. But then when we change Stacy's car color to peach, this will now be Stacy's information. Does that make sense? It's temporarily assigning all that information into Stacy. Once you hard code it in, it's going to stay there. But if something changes in John, it's going to go back.
So if you change the color in John, does Stacy's color change too, or?
No, because you've set Stacy's color to be a certain color.
Okay.
It would just be the make and the year. Is it? Yeah, the make. All right. Is there any questions on that? How we assign a reference variable? The best way to do it is to, instead of doing that to where we can lose that information, you want to assign a reference variable. In other words, you want to instantiate your own car, so everything, you're going to copy this and put it down here, but then you're going to reset everyone's information. Does that make sense? But you can also just reinitialize it the same way and then not have to worry about it. So which one's going to be better?
Try this way.
Now, if everyone had a 2008 Toyota, would it be easy just to do the other one?
Yeah.
Yeah, fine. It would work, right? Until someone changes the car, or whoever the first one was that all the objects are pointing to. Okay? Now let's talk a little bit on this next slide that I'm going to show you. I'll show you the make copy command. Okay? Now make copy is not a Java class. I mean, it's something we would have to make. All right? Does that make sense? It's not a class, but a method. What we're going to do is we're going to declare a local variable named car, and we're going to initialize it with car. We're going to call the calling object's car instance variables into that local variable, and then we're going to return that method or the information back. Okay? So now let me show you. John's car, new car, Stacy's car, right? We set the 3, correct? Now all you do is Stacy's car is going to equal a make copy of John's car. Y'all with me so far?
Yeah.
Then we can set the color to peach. So now they're completely two different objects instead of
One depending on the other.
one depending on the other. Exactly.
So you can change Toyota in 2008 without causing a problem.
Exactly. Because what we do is we have our private variables. We have our make, year, and color, right? We've already defined that. Noah is in the public class. Here's our method for make copy, creating our new instance of car, the car make, year, and the color. Now, what are we going to do? We're going to return car. So that's all 3 of these are going to come back out to create this copy.
Right.
It creates that other method, or a duplicate method, I should say, with the same information that was already sent in. So now, here's another problem that we can run into. Using the equality operator, I kind of touched on it a little bit earlier. If we use the double equals, the comparison operator, and we have any value that's already assigned to it, it will never be equal. Now, if you were just looking at it, would that make you think that it's equal? Car 1 equals new car 1 set colors to red, car 2 new car 2 set equal to red.
No.
You would think, by looking at it, that it would be equal, right? Both of them have a red car.
No, because
But there's that make and the year. Correct?
right.
So are they possibly equal? No.
Possibly.
Possibly, but more than likely not.
Right, because they're not all in the same space and memory.
So, exactly. That's why they're not equal. So if you did it this way, what is it going to come out to be? It's going to come out to be different. Now, if I just said car 2 equals car 1, and then if car 1 equals car 2, would that come out to be correct?
Yes.
Yes, because I've identified them to be identical in every way, shape, and form. Okay? Because I've assigned car 1's value to be in car 2. So yes, they will be equal, correct? So they would come out to be the same. But is that really the way you want to do it?
No, because one question, doesn't that make both car 1 and car 2 point to the exact same space in memory?
That's what I said a moment ago. Good job.
It does. And so would it technically be correct? Yes, they would be equal. But do you want to do it this way? Absolutely not. You want to use what we call the equality method, right? Y'all remember that from chapter 5, like I talked about just a few moments ago. We're going to use the equals method right here. It'll be inside the object. We're going to come down here. If we're going to have Jacob car and a Brandon car. We've set car 2 method, right? Or car 2 class. Both of them being the 2 different cars creating. If Jacob car dot equals, right? Equals is the sub method. Brandon car, which is the variable that we're doing the comparison to. If the 2 of them equal, is it going to equal? It will return the Boolean variable. Turn the variable true or false, right? Yes. Everyone in sleepy land? Y'all need some Mountain Dew or coffee to wake you up this morning? Okay, so suppose that we're going to pass a reference variable to a method. Inside the method, you update the reference variable, instance variable, right? What would happen? What would happen? We passed a reference variable to a method. Inside that method, you update it, the reference variable, instance variable. What happens? You just update it, but you didn't return it, so we don't know what you got. Right? Because it becomes primitive inside of here. Or I mean, not primitive. It becomes a local variable.
It's changed in there, but
It's a local variable, but it's not a global variable. Exactly. So now that it holds this address of an object, but not the object itself, right? So it's not assigned to that object. So once we pass it back, we get that object's address in memory. We can actually get that data and then show it and print it out and do whatever we need to. Does that make sense? Unless you return that variable, we don't have any information to go off of. So how do we do this? Let's walk through the main method. We've identified two person objects that are instantiated, right? Person 1, person 2. We use the set name mutator to assign Zachary to the first person, right? Here's where we're mutating it. Y'all remember that, right? What does mutate mean? Change, especially if it's a set. That's your keyword, set. If I'm setting something, I'm mutating it. I'm changing it. If it was a get, what kind of a method would it be? Accessor. Correct. So we've got that. Then once we use the get name down here, we're getting person 1's name, right? And person 2's name. So we'd have Zachary, comma, Eric, right? What if we did person 1 swap person 2? Well, how do you swap variables? Let's kind of talk a little bit about this.
We need a third variable to.
You need a what?
When you do inside the swap person method, you'll need a third variable. So you
Very,
can start
very
assigning
good.
things around.
Reason being, because if I did A equals B, B equals A, what have I done? I've now said if A was 3 and B was 8, I've now put A after this one, it'll be A is 8 and B is 8. So if you come down here, B is already 8, right? Because A is 8.
Right.
So did I mess it up? Yes. What you need to do is you've got to have what we call a temp variable. So we do temp is going to equal A, then A can now equal B, and B now equals temp. So what we did is we stored the variable of A, so temp is 3, A is 3, and here we now have A is 8, B is 8, and down here we're going to have temp was still 3, right? Now B is 3. Did y'all get that?
yeah.
Pretty self-explanatory, right? And that's what we're talking about when we're talking about in the swap area. So like I said, if we did X is 3, Y is 8, except I used A and B, same algorithm here. X would be 3, Y would be 8. But if I did the swap code here, they'll both be 8. Right? Like I showed you. So what we want to do is have that temp. We'll initialize temp as being a string because this is a string name, right? The name of the individual is a string. So temp is going to be that other person's name, which in this case was A. A name will be assigned to temp. Then that other person's name will get whatever this is, which was person 1 that was added in, right? I should say this is person 2. And then we switch it back to temp. Does that make sense? So we just swapped the information. Why do we have, what is this name? What does this stand for?
This is the one.
Remember from last chapter?
Is the one in the global or is
Nope, it's this instance.
Okay.
We're talking about this person, this instance, what we call. Okay? A method call. What is a method call? Well, that's when we define this method and we set a variable into it. We've called this method and we're assigning a variable to it, right?
Mhm.
Pretty simple. Set make to be in Toyota. It's a mutator. Mutator method, assigning it to the John Carr reference. Same thing with the 8. So when I talk to you about doing a method call chaining, what is method call chaining? It means we're stacking it or we're concatenating it. You remember that word concatenation probably from Microsoft Office class or other your programming logic class, right? Where you concatenate it. So the students in this class would be student 1 dot student 2 dot student 3 dot student 4, right? John Carr is going to be dot set make, and I'm assigning Toyota to that. But then I can do dot set year where I'm chaining and adding another method to it. It's still assigning it to John Carr. Do y'all caught that, right?
Yeah.
And that's all method call chaining is. Now, it's a good way if you don't have a lot of objects. But it can come back and hurt you. Okay? So let's examine this particular method. Remember, everything in English goes left to right, correct? Same instance when we're talking about a method call. Car is going to set make to Toyota, right?
Uh-huh.
So that would be the first thing it does. Then car set year would be 2008. Car print it. Does that make sense?
Yeah.
We're going left to right. Now, what does the set make return? How did we get this information to return, right? Then we set the year to 2008 and do the same thing to return 2008. Then we return the object information into print so that it can send it out. So let's look at it, how it does this, right? Our set make, we got that Toyota coming in here, right? The make is a string variable called make for our local variable make. When we pass it in, we've got Toyota. So this make is a Toyota. This make comes from right here. So that when I had John Carr, and I said set make, right? Y'all with me? This comes into here. Does that make it easier to understand where data comes from? And then all we're doing is saying this make is going to be Toyota. So we're going to return this value back out. It's kind of crazy, but that's the way it works. Do the exact same thing for the year. We have an integer year. The integer was 2008, came in. We assigned the year variable to this instance. And we returned this instance year back to the printout, which is down here. And y'all can't really see it, but all it says is, I want to see this make, which is right here, in this year, which is right here. So what would my output be?
Toyota, comma, 2008.
Exactly. I guess it would help if I erase that before I go on to the next slide. All right. Car 3, the next method. It's set making year. Note that we've enabled the method called chaining for this particular method. But when we do that, we have to return this instance, right?
Mm-hmm.
So y'all saw that in the previous one, we had to return that variable back. So if I did public car 3 set make to string make, what would, even though method chaining is optional, why would we use it? Give me an instance where you would want to use it.
Elegance. Easier to code.
Elegance,
Easier to understand.
easier to code, easier to understand,
Less
and
space.
it's compacting it. So you don't have 4 or 5 of the exact same thing, like this. How confusing can this be?
It can get very confusing.
Right? However, and I'm just using this example, this is what we call an overloaded method. An overloaded method is where you use the exact same validate, or in this case, where we have multiple functionalities, or the same functionality using on multiple instances, The difference being what it's returning. So these are kind of a little bit different methods here. So what's wrong with that solution?
It's harder to read.
Mm-hmm.
It's verbose.
Wouldn't it be easier just to use Boolean validate?
Yeah, learn one word instead of 15 million words.
Right? Because each method is different. Even if I just use the word validate, each one of these is different because you have string word, int number, and each one of these are in different orders.
Right.
So therefore, you can have 4 different ones, all with the same name.
And the only difference would be what it returns.
Exactly. So the computer sees it as completely different.
Alright.
Now you can't have 2 that would return string word that would be validate because they would look at, oh, wait a minute, that'll be a compile error. Okay? So a better solution for overload methods would be like alarm.validate and then give the information in here. Notice that we have different ones, different data that's coming in, right? Different variables that are being passed to it. Now they're all validate methods, right?
Alright.
But for this particular instance of alarm, you're sending all these in, right? Any questions on that? Let me put this into a better perspective for you here. We're going to talk about a height program, okay? How tall someone is. And we're going to be able to convert it a little bit later into the units, whether it be meters, feet, whatever. This height, we're getting in centimeters, okay? We're going to use the units being centimeters and the height being how many centimeters. They give us a number of 180 centimeters. So we're going to assign 180 centimeters to this height. This unit is going to be centimeters, right? So what are we returning anything in here? No. Hey, wait a minute. I've got another public void set height. What's the problem with that? You see a problem? We have 2 methods with the exact same name. Is that a problem? No. Because now I have a different type of parameter that I'm being passed. So long as these parameters, if I had not used string units there, then we would have had a problem. Does that make sense?
Yes.
So height and units. So in this case, I'm passing centimeters down. That's really the only difference between these 2 methods. Okay? Print out this height, this units. So which one is it going to be printing out?
Well, the first one's hard-coded, so you can't change it, but the second one allows you to change it.
This unit. This is this units. This is this units. Which one is it printing out? Which one of this height is it printing out? Because what happened? Okay. Oh, that's the alarm. Anyone got a guess?
Wouldn't it be printing out centimeters?
Do what?
Wouldn't it be printing out centimeters?
What was the information requested on the input?
Nothing yet. That's why you don't know. So let's come over here. Now let's look at the driver. Okay? We have our main method. We're setting 72 in inches, right? So if I did my height print, what is it going to come out? It's going to come out 72 inches, right?
Alright.
Then I do 180, but I don't put anything in here.
That would be
If
centimeters.
if there's no other thing in here, that's what we call a 0 parameter. So it's going to default back to the default. So what is the default parameter? Since there is no string units, because I didn't tell you what type of units, it'll default back to this one, right? So what is it going to be?
180 centimeters.
180 centimeters. Does that make sense? Have I lost anyone? Chad, you okay? You good? Matthew, you good?
Yeah.
You sure?
I think so.
Going once? Okay. So all we did for each time we called the set height program, and we pass this in there, it looks for what the parameters are, matches it up in that class for the method that matches that same set of parameters in that order and then does that. If it has a 0 parameter for either or the height or the units, if there was one particular way to do it, one parameter, then it would do it that way. If not, it's going to give you a compiler error because there's no plausible parameter value to be stored. Does that make sense? All right. Suppose that you've overloaded methods and you're inside one of the methods. Notice it's okay to call one of the other overloaded methods inside that method. So if I'm in set height and I got double height, and then I want to call set height with that height, then add centimeters is my second variable. So what we're doing here is I'm in this one, I'm in this one, and then instead of this height, I'm going to set it to set height, being or set length or set units being centimeters, and I give that this set height and give it this information. It would come down to here. Does that make sense? And that's what you would do there. Now we have constructors. What is a constructor? Before you were using mutators, where you would actually mutate the instance of that object. But what is a constructor?
It initializes the variables for the object.
Remember, when we declared it initially, we could do car, ramen car with the new car, right? We initialized it right there. And then we put it in here. Can we put it all in one? Yes. We can call car, ramen car, new car with all this information. Just as it is down here. All a constructor does is it lets you specify what happens to an object when it's instantiated with new. That's really all a constructor does. It's called automatically when the object is instantiated, and it's got to be the same name as the class. And don't put a return type at the left of the constructor heading, because constructors never return anything. Which one returns stuff?
Mutators.
No, assessor. Because you've got to access it to pull something back. Mutators, you're changing your variables. You're changing your instance. Does that make sense? Okay. Example, the car class with the constructor. We have our constructor of car 4 with all this information, right? Julio's car is going to be car 4 with this information. James' car will be car 4 with that information. So if I do system out print line, Julio car get make, what is it going to do to me? It's going to get the make of it, which will come back as a Prius, right? Why? Because that is an assessor. Example, the car with constructor. Again, we say this, make your model color. And all we do is we return the make back, is what we did. We're reading in a string M, Y, and C. That's what we got from that constructor definition that we passed to it. This get make is looking for this make value, which is right here, reads it in, and returns it back. So if you're going to do it with the constructor, when you're initializing it right off the bat and passing it to, you have to have an assessor method to get it back. Does that make sense? I'm just looking, let me get over here. The rest of those were basic, going over the same thing. Constructor overloading occurs when there are two or more constructors with the same name and different parameters. Again, if you have different parameters, they're going to go to different methods, right? Depending on the parameters that you're using to send in. That's all it is. Now I've got my class over here. Fraction in n. So this n is going to be a 1, right? So I'm calling this instance a fraction where I have an n and d is what? A denominator with 1. Numerator, denominator in 1, that'll give me a quotient. This quotient is the double of this numerator divided by this operator. You come over here, just shows how you do it. And here's your fraction. Hint, 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 hint. Hint, 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 hint. Do I need to say any more? Hint, 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 hint.
That's the homework.
It's a homework assignment.
Do I need to say any more? Hint, 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 hint. Y'all caught that, right? Okay, instance constants. Sometimes you want an object's attribute to be a fixed constant. In other words, if it's going to be a fixed and you're not ever going to change it again, what do you put in front of it?
Final.
Final. Public final string name. So why is name in uppercase? Because that declares it being a final variable. It will never change, like pi. Right? Doing the same thing. The name will never change. The name has changed to protect the innocent, right? Didn't you do a lot of that, right? No, I'm just kidding. And then you do last seen. Last seen is the integer. And that's how it does it. All right? Any questions on those constants? Let's class variables. Y'all know about class variables. The scope of that. You can access a class variable from anywhere within inside that class, right? That's that global variable inside the class. The constant contrast with an instance variable, which you can only access from that instance, right? Or the local variable. Makes sense? Like I said, some of this we've covered many times this semester. You have a local variable, an instance variable, and a class variable. Local is the very smallest. Instance applies to that object, or the instance of that object, and class gives you everything. Pretty straightforward, right? I'm not going to go through class constants because we've already talked about what a constant is. If it's a constant, it's in what kind of case? If you have a constants variable, how do you define it, and what case is it in? But constant's never going to change, right?
That's a final.
So it's a final. In what kind of case is a final in?
All uppercase.
All uppercase. All right, ready? Java's garbage collector does what?
B.
B is correct. It searches for inaccessible objects and converts their space to free space.
Same name, different parameters.
Exactly.
B.
Yeah, absolutely correct. Y'all are doing good. I must have really done a good lecture this time.
B.
B, static. Because have we ever done a shared or a group? Is there any questions on chapter 7? No questions.